Hello all. Today I have the pleasure of having a chat with one of the very few people I know in the industry that have a holistic understanding of it. Erik, nice to have a chat with you. It has been some time since I saw you face to face.
Yeah,
First of
hey
all,
Christos, thanks for having me on.
how are things in California?
Things are good, decent weather. School year's coming to an end, so got a lot of projects to finish before the end of the year. You know how it is.
Being busy is better than not being busy at all, eh?
Yeah, yeah, definitely. And I
That's
would say we've both kind of been exposed to a lot of different parts of the industry. Yeah, we've both kind of seen it from different angles.
Yeah, yeah, and this is definitely something that we have in common, apart from other specific interests that we have. But you have been busy indeed, all over these years of experience that you have with startups, with consultancy companies, now with being a part of an energy recovery company. So you have seen it all, and you keep
Yeah, I
having.
actually started my career at a water utility, so I've
Okay,
been on the side where we're serving drinking water to people. I worked on a new seawater desalination project in Indonesia, developing the entire project, including working with the customers to start delivering water to the village and to hotels nearby.
hmm
So I've seen a lot of different aspects of different projects.
yeah, and you keep have involving yourself with all kinds of different technologies or conventional systems now worldwide as part of your current role. So you definitely have a very wide range of experiences that you can connect the dots for what is happening right now in the water sector. No.
Yeah, I try to keep up with the latest. There's you kind of see trends, and so try to keep up as things change and move on to the next contaminant of concern or the next kind of new technology to figure out how real it is, what its niche is going to be.
And speaking about trends, what do you think about the latest trends on forward osmosis? It has been a big part of your professional experience, no?
Yeah. The startup I worked for was trying to develop, commercialize a new forward osmosis membrane. And even though, that membrane is really good, there's other good membranes on the market. The process is really challenging for, the water and wastewater side, just because the cost, most existing technologies are closer and closer to become commodities. So to be able to compete on cost, you really need a lot of volume, manufacturing volume, but you can't get manufacturing volume until get lots of orders. And so, with any kind of small new technology, it's good. I think Ford Osmosis found this niche in food and beverage,
hmm
concentrating fluids like coffee. You can pull so much coffee out of the water, it gets closer to the osmotic pressure of like 30% or 35%. You're talking about where we do with OIRO or with RO, where we try to get salts up into like 22% range. It's probably better. The higher osmotic pressure you go, it has some unique benefits, and it's kind of found that niche.
Yeah, yeah. Like we definitely see an application of the FO concept in the concentration of brines in the last 5 to 8 years, essentially. Now we also see it as part of an effort for membrane crystallization. And
Hmm.
it's something not new, right? Like there have been dozens of scientific papers on membrane crystallization with either MD or FO.
Yeah, and I would say there's probably a reason why it hasn't happened at scale yet. It's very, very challenging, to deal with any sort of membrane where you have crystals forming in the bulk solution and not either, cut through the active layer, scale the membrane. I know I recently saw a presentation just at EDS conference in Sharm el Sheikh in Egypt. I mean, it was great to see the data, but it's a very challenging application. It's going to be very difficult to unseat traditional crystallizers, in my opinion.
Yeah, yeah. I hope one day it happens because it will solve a lot of my problems. But
Yeah,
yeah, we definitely shouldn't overhype the people before we have some solid data in our hands.
Yeah, and I mean, it's hard because you see some presentations that are very promising and very exciting, but the details and the making it work, practically speaking, it's very difficult to get those kind of details out of the people doing this kind of research in these different silos in a way where, unless you're really plugged in or have experience with that or know how to talk to the right people, it's really difficult to kind of navigate how many of these technologies are real for the near term and how many are kind of still science projects.
Yeah, yeah. Don't get me wrong. Yeah, all power to testing out and research and innovation. And the more efforts we put into this, the more solutions are going to come. But you mentioned something that it's also a problem when it comes to working with new ideas in the water sector, and that is working in silos, essentially.
Yeah,
Yeah, not
yeah,
interacting with the bigger, let's say, water audience out there, and trying to make whatever you want to scale it up practically.
right, right.
So, what do you think
Yeah,
of that?
I have a lot of thoughts on this, but I think the first thing is, I was recently in the kind of NOWI 2.0 kickoff meeting, the National Alliance for Water Innovation that's being funded by the U.S. Department of Energy. And there's all this great research into all these, they're really doing some fundamental testing to kind of model and optimize the, osmotically assisted reverse osmosis, the OIRO, low salt rejection RO. But they're not really focusing on brine mining, and yet in NEOM and Watira, they have all this great research into brine mining, but they're not necessarily bringing in some of these new ideas from things like are happening at NOWI. So, it's frustrating because all this money is being spent, and it feels almost like a lost opportunity to not have more collaboration or more working together. Because if as you know, I mean, brine mining, a little bit more efficiency here, a little bit better process here can make a big difference in the final cost of your salt and can be the difference of the project going forward or not. And, it just takes time to get those lessons learned to go from this group to that group and have it actually tested at a sufficient scale for people to believe it's real.
And exchange of ideas would certainly get us faster to the target goal. That goes without any saying.
Yeah.
It's,
And
it's
it's,
not
and
it's
there's
not
some
like
people that
race.
are involved in all these different groups and I mean, there's people, I do see collaboration. There's definitely people involved in all these different groups and exchanging ideas. It's just, I've been talking to other people in the industry who are developing all these new things. And then we see a presentation and they're like, what they're developing would be perfect, but they're a little bit late. They were too late to get into that pilot. And so it's all just kind of theoretical. So, what's going to happen? It takes time. And
how would you foster a dialogue between the different entities? It's nice. Hey, it's nice that we complain and we rant, but
sure,
we're engineers. We should be out giving solutions, right? So, what's your solution?
Yeah, I mean, this is what happens at a lot of conferences when you get, at an IDA conference, IDRA, I should say now, or even at the EDS, it was great to catch up with some people who are very involved in some of the testing in Saudi Arabia and hear their presentations, because I wasn't aware of some of the data was very new to me.
Mm-hmm.
And I try to stay very up to speed on these topics. Probably having a dedicated sub conference at an IDA or at a Singapore Water Week or WEFTEC where a lot of people already come together, where it would almost be like a workshop where we set a goal for the industry, maybe this price for this sort of salt from brine mining or this energy use from OARO, and we let people talk. It's hard because there's also a lot of startups who have their own kind of business secrets and their own patents, and they're doing some really interesting work on these topics as well. It's kind of hard to find the right environment to kind of have the people who have all this knowledge in their head kind of get it together all in one place and challenge each other. That would be a very interesting sub-conference. I would love to see. If you want, we can try to talk to somebody and make that happen. That would be great.
This is why now I'm trying to create this kind online platform to allow
Hmm.
for easier exchange of ideas in between these big conference events. But and this is another topic I'll like to put later during this conversation. But you were telling me an example earlier about how US dealt with the development of the reverse osmosis. And
Yeah, you mean
how was that
when before
organized?
reverse osmosis was a existing technology?
Yeah. So how did they
Yeah, I'm
organize
sure
that?
there's well, I'm sure there's some senior desalters that know way more about this than I've only heard kind of secondhand. But there's a very concentrated effort. There was all this research coming out of UCLA and Los Angeles, but there was a U.S. government funded program that was putting a lot of money into developing commercial RO membranes.
Hmm.
And it wasn't being done by a startup necessarily, although there were startups that kind of spun out, fluid systems, and what's become, the DuPont membrane was kind of spun out of that originally. And, a lot of the core researchers went on to develop the membranes that are now sold under, the main names that now in the industry. But there was a very concentrated effort. The people who were involved in that were talking all the time. Once a breakthrough was happening, the scientific community that was working on that, or engineers, knew about that. When somebody was developing, new pressure vessels, people knew about it. People could test it. There was money to spend on it. There was money to demonstrate these advancements, and it was very concentrated, I guess. And there was a lot of, I'm sure it wasn't perfect, but there was a lot of collaboration in terms of everybody working towards the same goal. And you don't see that with a lot of technologies in the water space now.
Even research efforts here in Europe, everybody's fragmented. But I guess that there was a dire need. They saw the dire need of having to develop such a technology. Yeah,
Yeah.
and how do you think we can create such a need for current term purposes? Does it have? Do we have, for example, to reach the critical point of water stress worldwide, or can we somehow, for example, convey the message to the public in order for the latter to press the politicians to change legislations? Because to be honest, I don't see another way of pressing people to develop and use, let's say, the latest innovation in the market,
I mean, I
or
think it's
even
going to
bigger
be,
projects. Yeah, don't get me wrong. The conventional technology is well and fine.
yeah, that's a good question. So I think it's really going to depend on the technology. For things like the PFAS destruction technologies, which something I think a lot of people are very excited about. Regulations, when somebody requires, PFAS to be destroyed from an RO brine, or, you know, right now a lot of the projects in California are choosing ion exchange resins because it's, three times lower capex and opex than RO, or sometimes GAC, depending on the site conditions and needs. But those resins have to be disposed of. I think with the new rules, they have to be disposed of soon in toxic waste, facilities or dumps. They won't be able to go to kind of your traditional landfills anymore. And so as those regulations are going to drive certain technologies like that. But things like brine mining, I think one thing I'm waiting on is the demand for things like magnesium. There's only so many hard rock reserves. And if there was a significant increase in the demand for magnesium, it has to probably come from seawater. And so if that was cheaper than doing it electrochemically way, and I know there's some new startups really focusing on the electrolyzers. There's one near me called Magritia. So I think that's going to probably be more economic based and market driven. So
Theoretical
yeah,
speaking, fantastic.
actually you probably know more about that than I do in the brine mining space. So.
Yes and no. I cannot say with certainty, but I can certainly next time perhaps I can have a chat online with Nicholas Nelson from OMIA. I don't
Oh,
know if he was
yeah,
present in the EDS in Egypt, but he's definitely interested in the recovery of magnesium from brines. Look,
right.
in the end, you have two ways of getting the magnesium from brine. And this is something I would like to put as a general question out in the public. Either as chemical precipitation, and you can get it in low purity, low 90%, but it is relatively low and takes a lot of effort to reach the high purity we need. Or you can apply fractional crystallization or crystallization in general. You can take down the line as magnesium chloride, whatever, magnesium metal. But
Oh,
that
you
is
mean in
that
terms
is
of the brine mining technology to get to
to get
the
to.
substance that you're going to sell as magnesium? Yeah, got it.
But then, if you take it downstream, you have way more expenses. So,
Yeah.
what in the end is the best case scenario? Do you prefer a low purity, low effort process, or a high purity, high effort solution?
Yeah. And
So
that's
much to
where
do with the
talking to
economics.
people from the metallurgy world, you really need to include them in those kind of discussions. And yeah,
So you see again something that we talked about with we're talking a lot. We should invite people from other industries to attend the water events and exchange ideas and challenge us as water professionals. And we also were talking earlier about this. The hydrogen people should definitely be a part of whatever the
yeah.
water industry is doing right now.
Well,
Yeah.
I
So
mean, at EDS, that was great to have because there were some like people have been researching PEM type membranes. You know, the type of membrane, one of the ways you can make hydrogen is PEM type membrane electrolyzers. They've been working on that for like 20 years. So being able to pick his brain on all these things I read in the news or, I see different research, but how realistic is that from his perspective was great because, I was like, oh, I've heard all this about these high temperature membranes. Is that possible? And he was like, that's not something we're even close to today. And then talking to the guy leading that for Veolia, I'm not even sure how to pronounce his name correctly, Dionysus, I believe, but be able to pick his brain on what Veolia is seeing. And it was interesting to have the hydrogen world there meshing with the water world. And I think I realized the water world, we don't know that much about hydrogen, but we're learning. We know, learning what kind of quality you need for electrolyzers, obviously what kind of water sources are needed in the treatment processes, but also the hydrogen world was learning, what are the challenges with desalination and water reuse for ultra pure water, because the specs we've seen them, the water quality they need for ultra pure water for hydrogen are just it's really ultra pure, extremely low conductivity and salinity, and it's really a new paradigm in some ways for our industry.
I was wondering if we could use the waste heat from the electrolyzers for a
Mm.
membrane distillation concept to
That was
concentrate
a
brines.
huge topic of, yeah, there were probably like 3 or 4 presentations that talked about that. They didn't talk about the challenges of fouling with membrane distillation, but they talked about the use of waste heat. And there's waste heat, not just the electrolyzer, but if you go to the Haber-Bosch, from green hydrogen to green ammonia, which will probably be one of the biggest uses of green hydrogen. Right now, when you do the Haber-Bosch process, it operates at like 400 C, and all
Okay.
that waste heat goes into the steam reforming of turning the methane into hydrogen. So it's a very symbiotic process.
Mm-hmm.
And so there's a lot of discussion of how we reuse that waste heat in either thermal desalination. There's ways of generating electricity when you're at 400 C if you had enough. And then the fuel cells actually also have waste heat. So, can you reuse that and upgrade it for district heating or industrial use, membrane distillation? There was a lot of kind of side talks about that because waste heat came up in almost every single presentation.
So first of all, just I want to keep repeating myself on this point. Waste heat is not for free, and
No.
the way to transform waste heat to actually usable energy for membrane distillation or for any other concept, it's a complicated and costly matter.
And keeping it consistent. I think when people talk about waste heat, it's 6 degrees C. Well, is it 60 degrees C 24/7 or is it 60 degrees C part of the time, 40 degrees others? And I'm learning all about this because we have a new technology that helps recover energy and reduce the energy for heat pumps.
Mm-hmm.
So I'm getting way more exposed to this world and these ideas. And you're right. It takes quite a bit of investment to utilize waste heat efficiently, for sure.
But also, if you do find a way to transform the waste heat efficiently, then you have the need of upscaling the membrane distillation technology space efficiently.
Yeah. So I'm on the roller coaster with membrane distillation. I got super excited about when I first realized its potential. Then got really down on it when I realized how hard it was to deal with foulants. And then, but seeing some of the presentations was really eye-opening. There were definitely some niche projects related to hydrogen and what you're talking about that were really compelling. So I do think that actually might be one of the ways membrane distillation kind of grows more into the markets that we see. But I think just the utilization of waste heat in general is going to be a huge part of achieving net zero. There's so much heat that's wasted now, and if it could be utilized efficiently, I think that's a huge part of going where a lot of people want to go into net zero future.
So we have been talking about a lot of innovation up to now, but we see very little innovation in general being actually applied in industrial scale. So what is stopping innovation to be commercially applied?
I mean, I have a few thoughts on this, but I will say the innovation that happened in the last 50 years was quite significant. And a lot of the technologies we've seen implemented in the last 20 years, I'm thinking like in water, like MF and UF, for example, is really good. If there's not a lot of salt, it can achieve so many of the, the basic needs, or even things like biologically activated carbon with ozone and how that's being implemented into the treatment train for direct potable reuse in California. Like a lot of that research was done a long time ago. It's just now kind of found a way to be advanced into new applications. So I think part of it is just the technologies we have solve so many of our basic needs that the new technologies either they not only have to be better, but they have to be cheaper, which is a huge hurdle for startups to be able to do that without, they have to. I mean, I worked for Ford Osmosis startup where we were looking at all these different applications. We weren't sure where the best niche would be. We had some ideas. It didn't take long to figure out where the right applications to focus on were, but it was really hard to get funding to do those kind of demonstrations. And it was sometimes easier to get funding to demonstrate. Yeah, I know we're running short on time, but trying to find the funding for the right technology for the right niche is aligning those two things is very difficult in our current business market.
Just want to add on that well and fine, we have solved a lot of basic problems, but we also have a lot of new problems incoming and a lot of new ideas like brine valorization, I would rather call it like that want to be applied. And we have, for example, in the municipal waters, we have drugs, we have the PFAS that need to be taken care of. So we need to find new ways, of course, efficient, economically wise as well. But so the problems haven't stopped per se. I'd say the industrial wastewaters are going to become only more saline in the future. So we'll have to deal with this as well. And you'll have at some point, new legislations coming in about water reuse, to save water resources. So these things will have to be dealt with one way or the other. I'm just saying, how can we do it now instead of running like panic chickens 5 to 10 years from now? So
I mean, there's people developing, like NAUI is a good example. They're trying to develop these kind of online resources that kind of focus on these kind of new technologies and how they're optimized and how they're implemented. But the more knowledge that's out in kind of the public realm, for example, NEOM, it took a while before people started seeing some of the different kind of more optimized process flow diagrams. And then people started seeing that and having new ideas. Well, what if you did this? And how could you optimize it this way? And there's all these companies that have all these different types of expertise. So then we had to find somebody that worked for Whirly and be like, hey, have you thought of this? And then Whirly had to, then look at it and then communicate it to NEOM. So, and maybe it was too late at that point to get it into the demonstration system because that had already been designed. Maybe the next step, it can be, that idea can be implemented there. All that to say is, I think this goes back to those channels of collaboration and communication and there's definitely certain people in the industry that I go to, like Jim Lazier, who has a wealth of knowledge. But when I worked with him for a while at Jacobs, and he had heard about OARO and heard about all these benefits, but until we kind of walked through it, and he's even walked through it much more now, he didn't really understand all the levers that could be pulled and the strengths and the weaknesses. Just because until you do it yourself, or it's there's so many lessons learned you get in actually doing that first project or that first design, until more and more people have access to do those projects. It's
I have a lot of
yeah.
theories about commercial application and
Yeah.
scaling up, but perhaps this is a conversation for another time. We'll definitely have more chances to put our ideas online. But I would like to close our chat with a proposal, and this is that I think we should create some sort of online fireside chats
Yeah. Fireside
where,
chats.
where we periodically, let's say, update each other and challenge ideas
Mm-hmm.
online. I think anything between 4 to 6 people would be enough to start this collaboration, let's say, and exchange of ideas publicly for all
Mm-hmm.
people to see and comment and everybody to say their piece. So, like one-to-one conversations are well and fine, I guess, but we definitely need more people incoming to challenge what we're saying. Otherwise, you're always working within your bubble.
Yeah. That a lot of people would like to tiptoe around that because they might be challenging a customer. They might be giving away trade secrets. And so I think I love that idea. I think just finding a way where we can challenge each other and push innovation along in a way where it's good for the industry, but also people feel comfortable. And because at some point, if your technology really works, you kind of have to put out there and let it be challenged. And so finding people at the right stage of development, I think would be, I really like that idea. So,
Thank you for that. Eric, I have to thank you again for taking time out of your very busy schedule to have this chat. Take care, all the best, and I'll be looking forward to seeing you again online pretty soon.
all right. Sounds great. Thanks for having me.
Ciao, ciao.
Yes.